So in this video, I wanted to talk a little bit more about quadratics. So I've been making a little video series if you've been following along, and it has been covering basically the introduction to quadratics so far. So we've gone over just the basics, axis of symmetry, vertex, things like that. All of those things you should be a little bit familiar with now. So even if you're jumping into this series right now, you should be good if you know those things already. So today, if you already read the title up here, I'm going to talk a little bit about the factored form of an equation. Now, before I get into anything new, I always like putting something we already know. So if you've been following the series, we've probably already seen equations in the form of y equals ax squared plus bx plus c. Now, this form right here we call standard form. So we've gone over that before in the past few videos. We've even done a few questions with standard form and just identifying simple features. Now we're gonna talk about a new way of writing these equations. Like this equation right here can be written as something else. And we're gonna show how we can do that and what information we can gather from something like that. So I'm going to throw up the algebraic, or just the letter form, as I like to call it, of the equation. This is the letter form. But just the general form of factored form looks like this. You might see different ways of seeing it. So you'll see a, again, we have that a, and you have x minus r and x minus s. So you might wonder, well, how do we get from this to that? Well, there is a way of doing that, and we'll cover that in the next few videos, but this is essentially how it looks like. This is what factored form looks like. You'll have your a value up front. That could be positive, negative, and we know what that would mean, right? A positive and negative dual vector graphs. And you're going to have two binomials, or just a binomial here. So you'll have x minus r and x minus s. You might just have one binomial here too. It depends. But this is essentially how it'll all look like. And now, what does that actually mean, and what information can this give us? Well, I will tell you one thing. This equation here actually is a little bit more useful than this equation here. So what I mean by that is actually we can gather a little bit more information from this than we can from this equation. So I'm going to write out basically a quadratic equation in factored form, and we're going to work through what information it actually gives us. So I'm going to quickly erase this. Well, I'm just going to rewrite it again. So I'm going to write my factored form again. Y equals a, x minus r, x minus s. Great. So I'm going to write an equation in that form. Let me just pull that one up really quickly. Here we go. So y equals 2. X minus 4 and x plus 2. There we go. So this is basically an equation in factored form. So you might notice that, hey, there's no subtraction signs in both. There's only a subtraction sign in this one. There's no subtraction sign. You don't have to worry about that now. We'll actually see what that means a little bit later on, but don't worry about that. And actually, I don't like this up here. Let's just deal with the numbers first. I feel like letters confuse everyone. Numbers might be a little bit easier to deal with, first of all. Now you might wonder, why is this equation, as I said, a little bit more useful than the equation that we saw before, the standard form equation? Now the point that I'm trying to make here is that you see these two expressions here, x minus 4, x plus 2, these actually give us the zeros. And if you've been watching the previous few videos, you'll know what the zeros are. The zeros are where the graph touches the x-axis. So I'll make a really rough sketch now. My friend will actually put up this equation here, like the graph of this equation. But so imagine we had something like this, right? So these 2 points right here, where it touches the x-axis, these 2 points are called my zeros. So this expression here actually gives me the location of my zeros right off the bat. And when we have our zeros, we can do anything. We can even find the vertex and so on. So you might wonder, what are the zeros for this equation, or this graph right here? I'll put up the zeros, and I'll point out something important when we're finding the zeros from the factored form. So the zeros for this equation actually are, so the zeros are 4, 0 and negative 2, 0. So basically, you have in here two numbers, right? or these expressions each have an x and a number. So the number here is -4. Notice how one of my zeros is 4, 0, and the number here is +2. Notice how my other 0 is -2, 0. So basically, the zeros are given to us in here. All we have to do is we have to flip the number that is already in there. And the reason we call it zeros is because, let's take x minus 4, right? And we set it equal to 0. That's what it actually means. Well, if you solve this for x, all you have to do is bring the -4 onto this side, which makes it a +4. There we go. We got one of our zeros. And let's take the other expression, x plus 2 equals 0. And let's set it equal to x, -2. So there we go. Those are my zeros, 4, 0 and -2, 0. So as you can see from this equation, we actually get our zeros right off the bat. It's actually very simple and intuitive. So let's do one together. So I'll get rid of these. What if we had +5, x plus 5, and instead of -4 I had x minus 7, let's say. What would the zeros be in that case? Well, the zeros, again, you take the number in there. What is in there? -7? What's the opposite of -7? Not the reciprocal, just switch the sign. 7, right? 7, 0 is one of my zeros. And x plus 5, well, +5 is in here, and what's the opposite? Again, not the reciprocal, just switch the sign. It's -5, 0. Again, so it tells us the zeros right off the bat, and the zeros are actually very important to us, right? Because with the zeros, what we can do is we can find the axis of symmetry, and we can also find the vertex once we have the axis of symmetry. So for the actual equation that we had up there, I'm going to go back to that because that is a graph I can display for you electronically, and you'll see the final product. So what we're going to do here, let me just fix the numbers. Let me check what the numbers were again. X minus 4, x plus 2. Amazing. X plus 2. So we found our zeros, right? Our zeros were, we said, 4, 0, because -4 is in there. Just switch the sign. 4, 0. And 2, 0. Again, I made that mistake. Take the 2, flip the sign, -2, 0. So now that we have our zeros, you know what? We can even find our vertex from here. And before we find our vertex, let's find the axis of symmetry for the graph. Again, I'm doing all this without graphing it. I'm doing all this from the equation, and that's what the point is, to get information from the equation. So to find the axis of symmetry, I'm going to quickly do it over here. The axis of symmetry, if you remember, we're trying to find the x, or the line on the x-axis, or the y-axis, my bad, the line that separates the graph into half. So to find that, we have 2 points on the two sides of the parabola. All we have to do is we have to add our zeros together and divide by 2. That's all we have to do. So to find that, let's do 4 plus minus 2 divided by 2. So 4 plus minus 2 is just 2, divided by 2 is 1. There we go. So right there you can see my axis of symmetry right there is x equals 1. Because what I did was I took the two zeros, 4 plus minus 2 divided by 2. I found the midpoint, or the middle, where I can cut the graph in half, and I'll get the same distance from the middle. So I found the axis of symmetry. Well, how do I find the vertex when I have the axis of symmetry? That's actually very simple. All I have to do is take the axis of symmetry, x equals 1, and all I have to do is I have to plug it in to the equation. So I'll just write x equals 1 as my axis of symmetry. And I'll do this one right quickly up here. So if I plug in x equals 1, right? So 2, 1 minus 4, and 1 plus 2. Great. So 2, 1 minus 4 is -3, and this is 3, right? So 2 times -3 is -6, times 3 right here, equals 18. So the x-coordinate, or the y-coordinate of the vertex is 18, because we found that out by plugging the axis of symmetry into the equation itself. And there we go. The vertex, we can say, is 1, -18. Always put your coordinates in brackets, it's actually better. So how did we get the axis of symmetry? We added the two x's together, the two zeros together, we divided by 2 to get the midpoint. And how did we get the vertex? Well, all I did was I took the axis of symmetry, plugged it into the equation. And guess what? We can even get something else from this equation, and we can get the y-intercept. So if you remember what the y-intercept actually is, the y-intercept is when x equals 0. So the easiest way to do this is just set x equal to 0. Again, I'll do it quickly up here. 2, 0 minus 4, and 0 plus 2. So you have 2, negative 4, and positive 2. If you multiply that out, you get negative 16, because 4 minus 2 is negative 8, times 2 is negative 16. So the y-intercept actually occurs at 0, negative 16. See how much information we have actually just got from the equation itself? And my friend will actually put up the graph, and you guys will see that all of this information is actually correct, and we all gathered that from the equation itself. So now that we have the y-intercept, what else can we find there? Well, we don't really need to find anything else. Well, we can make a few more inferences about the graph. What's my a value here? 2, right? And it's a positive a value, so we can say the graph opens upward, because it's positive, a value, opens upward, and it'll have a minimum vertex, or the minimum value for the vertex. So again, my friend now, I think, will put up the equation up, not the equation, the graph of this equation up, and you'll see that all this information that we've gathered is actually correct. The zeros are at 4, 0, negative 2, 0. I found my axis of symmetry by using the two zeros, found my vertex by taking the axis of symmetry and putting it into the equation, found my y-intercept by just setting the equation x equals 0, and we also said the graph opens upward. We've actually made a lot of inferences from just the equation itself. So again, just to summarize everything that we have done in this video, we talked about factored form. Factored form is when you have y equals a x minus r or x minus s. The way I see it is I see two brackets or a bracket like that, or just brackets with x's inside them, and you'll know that it's factored form. And in this case, we had x minus 4, x plus 2. Again, be careful when you're writing the zeros. It's not negative 4, 0, it's actually 4, 0. So whatever number is in there, you switch the sign. Negative 4 turned into 4, 0, and 2 turned into negative 2, 0. These will give you your zeros. And that should be it. And last thing before I do leave, imagine that we had just 2x minus 4, right? You might wonder, well, does this equation have 1 0, 2 zeros? And that I'll talk about a little bit in my next video, where we do a little bit more advanced stuff with factored form. But for now, all you have to know is if you see factored form, you know your zeros right off the bat. You just switch the sign of the number in the bracket, negative 4 turned into 4, 0, 2 turned into negative 2, 0. That's all you need to know so far, and in the upcoming videos I'll talk a little bit more about factored form. I'll even tell you how you go from factored form into standard form, which is just simple algebra with polynomials. Nothing too complicated. So if you've been following along so far, all of this should be coming easy to you, and you should be able to do some questions throughout the textbook, whatever you're working through. And I hope you're enjoying these videos and they are being somewhat useful to you. Thanks again for watching.